High voltage transformer primary feeder overcurrent calculations. In this presentation, we're going to look at how we use table 50 and evaluate if we can omit the primary overcurrent for a high voltage transformer installation. First things first, let's do a quick review and just know that 26250 subrule 1 and 2 is only used when we are calculating the maximum primary overcurrent device that protects both the primary and the secondary of that transformer. There are separate rules for a fuse or a breaker, which is very common when dealing with high voltage due to the way in which the tripping element will function. If we're looking at a installation where we have a primary feeder coming off of a splitter and a disconnect on the primary, we have to then determine if it is permissible to do this by evaluating the size of the primary feeder over current using table 50. And then after it's confirmed that yes, indeed, it is okay to do this, then we have to go back to table 50 and determine the maximum size of secondary overcurrent. So table 50 is used for both of these. Well, let's take a look at an example with this and see if we can figure out how table 50 will be utilized. In this first example, we have a high voltage transformer. It's 38 kV on the primary, 4160 on the secondary, and we want to know, can we omit the primary overcurrent protection on this transformer? And that is going to completely hinge on the size of this overcurrent device. It is 20 amps. And so what we need to do is go to table 50 and use the primary current of this transformer and determine, is the overcurrent small enough here that we can get away with only putting a disconnect? So calculation, the primary current that we have for this transformer is 7.59 amps. When we go to table 50, we need to look in the primary side of the table. We need to look at fuse and also the percent IZ, which in this case was only 7%. Using all three of those pieces of information, we can then go to table 50 and find the multiplier, which is 300%. 7.59 times 3 gives me 22.77 amps maximum. So put it into context, what it's telling me is that if the primary feeder overcurrent is 22.77 amps, that would be the maximum size it could possibly be, where we could still remove the primary overcurrent and put a disconnect in instead. So in this situation, is it permitted? Yes, it is permitted. And so we can place a disconnect in that location. The second step is then to determine what size of secondary overcurrent is the largest that I'm permitted to put on. Remember, the secondary overcurrent is going to protect the secondary conductors going off to the load. So first we need to know what type of overcurrent it is, either a fuse or a breaker. We are going to use a breaker in this installation. And so again, we have to go to the secondary side, high voltage in table 50, 7% IZ, and determine what the multiplier is for this item. The secondary current is 69.39 amps. The multiplier given is 300%, which gives us 208 amps. Now we're going to take that value to table 13, and you'll notice from our rule of 26250 subrule 4, there is nothing in there that says we may proceed to the next larger standard available size, and there's nothing in table 50 that states we may go to the next available size. And so because of that, we have to choose or treat this as the absolute max, and we have to choose the next size standard rating down from the number we calculate. So 200 amp overcurrent would be the maximum size secondary circuit breaker we would be permitted in this installation. Let's take a look at another example. This one is going to be very similar, but what we're going to have now is a secondary that is low voltage. Now remember, high voltage transformers are labeled high voltage because the primary is high voltage. Sometimes the secondary is high voltage, sometimes it's low voltage. But if either side of that transformer connects to high voltage, it's automatically categorized as an item of high voltage equipment. So what we want to do is determine, is it permissible for me to omit the primary over current? The way we do that is we go to table 50 and we find a multiplier that we're going to apply to the 100 amp primary feeder over current. Now we've got an 8% IZ, we've got a circuit breaker on the primary. And so with that information, we can find the multiplier with the primary current of 27.75. We multiply it by 4 or 400%. So what this number here tells me is that yes, I can omit the primary over current for this transformer because the primary feeder here does not exceed this number. Put it another way, this is smaller than the number I calculated. And because it's smaller, I am permitted to omit the primary over current protection for the transformer. So we're going to put a disconnect in there. And now that we've determined we're going to remove the primary over current, we have to determine the size of the secondary over current that will protect the secondary conductors. We need to again know what type of overcurrent it is, although it's not as important in this situation because it is low voltage on the secondary. So low voltage secondary, 8% IZ, we do a calculation with the secondary current and we come out with 192.45 amps. Now what this is showing us is that a 2.5 multiplier or 250% is applied, which gives us an absolute maximum secondary overcurrent of just over 481 amps. We go to table 13 and choose the next available size lower. Remember, we cannot exceed 481, so we have to go lower, and that gets me to a 450 amp overcurrent. All right, so last example we're going to do with this. Again, high voltage transformer. This time we've got a 25 amp primary feeder overcurrent on a 12 kV incoming primary to a 4160 volt secondary 300 kVA transformer at a rather hefty 9% IZ. First step, determine if we can remove or omit the primary overcurrent. We go to table 50 and we find the multiplier for this particular installation, which is a fuse, high voltage, and 9% IZ. Table 50 says 200% multiplier is what we apply. The primary current of my transformer is 14.43 amps times 2 gives me 28.86 amps. With this number, we can see that the primary feeder overcurrent does not exceed the calculated maximum, and because of that, it is permissible for us to remove or omit the primary overcurrent device for this transformer. The second step to this is then to determine the maximum size of secondary overcurrent to protect the secondary conductors. We need to know what type of overcurrent it is. We're going to use a circuit breaker this time. And the circuit breaker with the high voltage and the 9% IZ will then give us a multiplier of 250%. So 41.63 amps times 2.5 gives me 104.07 amps. Again, we are not permitted to exceed this maximum, which means when we go to table 13, we must choose the value that is just lower than 104, and that gives us a 100 amp circuit breaker.